packing a whole house into a suitcase. Sounds impossible, right?
Yeah, well, that's basically the challenge we face trying to launch large structures into space.
Exactly. And that's where in-space manufacturing comes in. Today, we're diving into this game-changing concept.
In space manufacturing, or ISM?
Right, ISM. We're going to explore how it's revolutionizing space exploration and what it means for the future. With me is expert title, no name. Thanks for joining me for this deep dive.
Glad to be here. ISM is definitely a hot topic right now, and it's only getting hotter.
So let's break it down. ISM, building things directly in space instead of launching them from Earth. Why is this such a big deal?
Well, it's a total game changer for a bunch of reasons. First off, think about the cost and complexity of launching stuff into space.
Yeah, those rockets aren't cheap.
Not at all. And they have strict limits on size and weight. It's like trying to fit, like you said, a house into a suitcase.
A very expensive suitcase. Plus, there's the risk of damage during launch.
Absolutely. And what happens if something breaks once it's up there? Sending a repair crew is a whole other nightmare.
So ISM tackles all of those challenges. We can finally break free from those limitations.
Exactly. With ISM, we're not just launching things, we're building them right there in space. We use materials already found out there.
Like lunar regolith. That seems to be everyone's favorite space buzzword these days.
It's more than just a buzzword. Lunar regolith, or space dirt as some call it, holds incredible potential for construction.
Okay, I'm intrigued. So we're talking about building structures on the moon, using materials found on the moon.
That's the idea. And with 3D printing, the possibilities are pretty much endless. We're not just talking about simple structures either.
3D printing in space, huh? I know they're doing some of that on the International Space Station, but I thought it was mostly for small tools and stuff.
The ISS is definitely a testing ground for these technologies. They're printing tools, replacement parts, all kinds of things.
That's amazing. So the ISS is like a stepping stone to larger scale ISM projects.
Exactly. It's proving that these concepts work in a real space environment, and it's paving the way for even more ambitious projects.
So what's next? What kind of large-scale projects are we talking about?
Well, let's talk about NASA's Archinaut program. They're developing robots to assemble massive structures right there in orbit.
Archinaut, I've heard of that. Weren't they working on those huge solar arrays, the ones too big to launch from Earth?
That's the one. Imagine giant solar panels being assembled in space, providing power for, well, pretty much anything we can think of.
Okay, so we're talking about structures that would be impossible to launch in one piece, suddenly becoming possible.
Exactly. We're no longer limited by what we can fit into a rocket. We can build structures of almost any size and complexity. Think space stations, telescopes even.
Shipyards, like actual shipyards in space.
It might sound like science fiction, but it's closer to reality than you think.
So how does this all work? How do you actually assemble something that big in space?
It all comes down to modular design. Think of it like building with Legos, but on a much grander scale. Space Legos. I like it.
Each module is designed and built on Earth, tested rigorously, then launched into space.
And then robots snap them all together.
It's not just robots, although they play a crucial role. We're also exploring something called self-assembling structures. Imagine materials programmed to, well, almost build themselves.
Hold on. Self-assembling structures. Is that even possible? It sounds like something straight out of a movie.
It's more real than you might think. There are already prototypes for self-deploying antennas and solar panels.
So we're talking about materials that can unfold or connect autonomously, like a high-tech origami project in space.
That's a great analogy. And researchers are working on even more complex self-assembling structures.
It's pretty mind-blowing. We're essentially creating a whole new way of building things, a whole new way of thinking about construction.
It is, and that's really just the tip of the iceberg. ISM is evolving so rapidly it's hard to even imagine what the future holds. Well, I'm definitely on the edge of my seat. But before we get too carried away with future possibilities, let's bring it back to Earth, or at least back to the basics. How do we actually hold all of these massive structures together in zero gravity? I mean, it's not like we can just use nails and glue, right?
You're right. Traditional construction techniques just won't cut it in space. We need something a little more cosmic.
Cosmic, do tell.
We're talking about tethers and tensioning systems. Imagine a network of cables and struts, kind of like a giant space web holding everything in place.
So like a suspension bridge, but in space.
Exactly. It's a whole new way of thinking about structural integrity.
It's like we're defying gravity with engineering ingenuity.
That's a great way to put it. We're using the laws of physics to our advantage, creating structures that can withstand the unique challenges of the space environment.
So we've gone from packing houses into suitcases to building giant space webs. This deep dive is already blowing my mind.
And we're just getting started. We haven't even touched on the amazing possibilities of space repairs and what that means for long-term missions and sustainability in space.
That's a whole other chapter in the ISM story.
A fascinating chapter indeed, and one that we'll definitely be diving into after a short break.
Okay, so space repairs. It sounds kind of tricky.
Tricky. It's a whole different world up there. Zero gravity, extreme temperatures, radiation, the vacuum of space.
Right, it's not like you can just pop the hood and tinker around like you would with a car.
Exactly. And forget about calling a tow truck if something goes wrong. We're talking about fixing things millions of miles away from Earth.
So how do we even approach repairs in that kind of environment?
Well, the first step is designing for reparability from the very beginning. We're talking about modular components, standardized interfaces, making things as easy as possible to access and replace.
So it's like building a spaceship with Legos.
You got it. If a part breaks, you swap it out with a new one.
Yeah.
But the real game changer here is robotics.
Robots. I mean, I know robots are becoming increasingly sophisticated, but can they really handle the complexities of space repairs?
They're not just handling them, they're excelling at them. We're talking about robots that can perform incredibly intricate tasks. Think microsurgery, but for spaceships.
Wow. Robot surgeons for spaceships.
Yeah.
What kind of things can these robots actually do?
Well, they can inspect damage, tighten bolts, replace components, even perform welding tasks. And they can do all of this autonomously without any human intervention.
Are there any real-world examples of this?
Absolutely. Take a look at NASA's Restore-L mission. They launched a robotic spacecraft that actually grabbed a satellite, refueled it, and then released it back into orbit.
Refueling a satellite in orbit. That's incredible.
It is, and that's just the beginning. We're talking about extending the lifespan of satellites, upgrading their instruments, maybe even repurposing them for entirely new missions.
So not just repairs, but upgrades and even repurposing. That's a whole new level of sustainability in space. We're getting a lot more mileage out of our space investments, so to speak.
Exactly. And speaking of sustainability, remember that 3D printing we talked about earlier?
Yeah, building stuff with space dirt and lasers, right?
No, 3D printing isn't just about creating new things. It's also an amazing tool for on-site repairs.
So instead of launching a whole new part from Earth, you could just print a replacement right there in space.
Precisely. Imagine a small crack in a critical component. You just print a patch or even an entirely new part, and you're good to go.
It's like having a mobile repair shop right there in orbit. That's got to be a game changer for long-duration missions, especially when we're talking about sending humans to Mars and beyond.
Absolutely. Being able to fix things quickly and efficiently is crucial for mission success. And it's not just about convenience, it's about resilience.
Resilience, in what sense?
Well, think about it. If something breaks down on a mission to Mars, you can't just call for a rescue team. You need to be able to fix it yourself.
So it's about self-sufficiency, being able to adapt and overcome challenges in a hostile and unforgiving environment.
Exactly. And that's where things get really interesting. Researchers are exploring even more futuristic repair concepts.
Yeah.
We're talking about self-healing materials.
Self-healing materials,
Yeah.
like Wolverine-style regeneration.
Not quite that dramatic, but you're on the right track. Scientists are developing materials that can sense damage and then initiate a self-repair process at a molecular level.
So it's like giving our spacecraft an immune system. They can heal themselves.
That's a great way to put it. It's all about making our spacecraft more resilient and adaptable, able to withstand the rigors of the space environment.
It sounds like the future of space repairs is all about automation, resilience, and pushing the boundaries of material science. What a time to be alive.
It is an exciting time, but as we venture into this uncharted territory, it's important to remember that technology is only part of the equation.
What do you mean?
Well, with all of these advancements in ISM, we're facing new challenges, and not all of them are technical. There are ethical and societal implications we need to consider.
Ethical implications.
Right.
Like what?
Well, for starters, who gets to build and repair things in space? Is it a free-for-all? Do we need some kind of international regulations?
Right, we can't just let corporations or governments claim space for themselves.
Exactly. Space is a shared resource, and we need to figure out how to manage it responsibly.
And then there's the issue of space debris. The more we build in space, the greater the risk of collisions and the creation of even more debris.
It's a serious concern. We need to be very careful about the environmental impact of our activities in space. We don't want to call it a cosmic junkyard.
It sounds like ISM isn't just about technological innovation. It's about finding a balance between progress and responsibility.
Absolutely. We need to approach ISM with a sense of stewardship, ensuring that our activities in space benefit all of humanity, both now and in the future.
It's a lot to think about, but it's also incredibly inspiring. We're not just talking about building things in space, we're talking about building a better future for humanity.
That's a great way to put it. And I think that's a perfect segue into the final part of our deep dive.
You're right, we've covered a lot of ground, but there's still so much more to explore.
There is. And when we come back, we'll delve into the future of ISM and what it all means for the grand adventure of space exploration and the future of humanity itself.
We've gone from packing houses into suitcases to self-healing spacecraft and robot repair crews. It's mind-blowing how far we've come with in-space manufacturing.
It really is. We've turned what seemed like a science fiction concept into a tangible reality. It's incredible to see how fast this field is moving.
Yeah, moving at warp speed. But with all this progress, it's important to ask, what are the long-term implications of ISM? How does all this shape not just space exploration, but humanity's future?
Those are the big questions, aren't they? The ones that keep me up at night. And I really think the answers come down to how we approach ISM, not just as some set of cool tools and technologies, but as a reflection of our values, what we want for humanity.
So it's not just about what we can build, but what we should build, what we choose to build.
Exactly. Think about it. If we just see space as a resource to be exploited, we're basically repeating the same mistakes we've made here on Earth. But if we approach space with a sense of responsibility, a sense of stewardship, collaboration, then ISM, it can be a catalyst for a much more sustainable and inspiring future.
A future where space isn't just some far-off destination, but a true extension of human civilization.
Right, where we can live, work, discover. Imagine self-sustaining habitats, thriving ecosystems in space. Think about the possibilities. Scientific outposts that unlock the secrets of the universe. Maybe even use ISM to develop technologies that help solve problems back here on Earth.
It's like opening a door to a whole new chapter in human history, and ISM is that key.
A key that unlocks not just technological advancements, but a whole new way of thinking. Imagine a world where, because of the challenges of space travel, the need to be resourceful and collaborate, that actually helps us solve problems here at home.
That's a fascinating idea. So the constraints of space could actually inspire solutions for a more sustainable and equitable world back on Earth.
I think so. Look at how we have to conserve resources in space. Look at how we have to work together. Those lessons could be invaluable back on Earth.
So ISM isn't just about building things in space. It's about building a better future for humanity wherever we are.
Exactly. Expanding our horizons both literally and figuratively. Pushing the limits, inspiring new generations to dream bigger.
And speaking of inspiring future generations, what would you say to someone who is just captivated by ISM, wants to be a part of this incredible field?
Oh, that's easy. Follow your passions, whatever they may be. Engineering, robotics, material science, even space law and policy, there is room for everyone in this field. Read, learn, connect with others who share your interest, and never stop asking questions. That's the most important thing. Never stop being curious.
That's great advice, and I think it's the perfect note to end on. The future of in-space manufacturing is wide open, full of possibilities, challenges, a lot of uncharted territory. But it's a future we get to build together, one step at a time.
One innovation at a time, one breakthrough, one crazy idea.
Absolutely. And who knows, maybe years from now, we'll look back at this conversation and be amazed by how far we've come.
That's the beauty of it. We're on the verge of something truly extraordinary. I can't wait to see what unfolds.
Me neither. And to everyone listening, keep looking up, keep exploring, keep those imaginations firing. The future of space is in your hands.
Well said.
And that brings our deep dive into the world of in-space manufacturing to a close. Thanks for joining us on this incredible journey. Until next time, keep dreaming big, and we'll see you in the vast expanse of possibility that is our universe.